So in this video, we're going to approach limiting an excess reactant stoichiometry by comparing the amount of reactants that we have to each other and then using those values in order to determine how much product we can make. So let's take this example where we have nitrogen reacting with hydrogen to make ammonia. It asks how many grams of ammonia can be produced from 56.04 grams of nitrogen and 8.08 grams of hydrogen. And then afterwards we'll figure out how much of the excess reactant we'll have remaining. So what I like to do first is write down what I'm given underneath the compound or species that is being described. So you have 56.04 grams of nitrogen. You have 8.08 grams of hydrogen. And first thing we're looking for is the number of grams of ammonia that will be produced. So what we're always going to want to do when we're comparing amounts of materials involved in a chemical reaction is go to moles. So we're going to take a trip to Mole Town and figure out how many moles of each substance we have. Then we'll figure out how much we need, and then we'll figure out how much is left over. So doing this for a nitrogen, 1 mole of N2 is 28.02 grams. So nice and cleanly here, we have 2.000 moles of nitrogen to start with. Now for hydrogen, 1 mole is 2.02 grams. So we have exactly 4.00 moles. So at this point, what we're going to do is take a guess as to which one we think we're going to run out of first, and then use what we find from there, what we find we do run out of first, to figure out how much product we can make. So looking at this, even though I have more moles of hydrogen, I know that I'm going to use that up at 3 times the rate of nitrogen. So my guess is going to be that this is my limiting reactant. And so what I'm going to do is I'm going to say that, all right, so if I know how much I have, now I'm going to figure out how much I need. And I'm going to need 1 mole of N2 for every 3 moles of H2 that I have. And what this gives me is a value of 1.33 moles of nitrogen that I would need to use up all of my hydrogen. And you can see that I have that much. I have more than that. So if I'm only going to need this much and I have more than that, I know I'm going to have some remaining. So I was correct in my guess. But let's say you did this and you got a value that you're going to need more than you have. Well, then you guessed the wrong limiting reactant, and you would say that the other one would be the limiting reactant. So I'm going to go from here and say that I have now established that this is going to be my limiting reactant, and I can use that molar amount to figure out how much of the product I can make. So then, I just have to use the molar ratio. Again, you can relate any 2 things in a chemical equation as long as you use the coefficients from the balanced chemical equation, and you did all that right. So I'm going to get 2 moles of NH3 for every 3 moles of H2. So then I multiply this out, and I find that I'm going to be able to make, from my limiting reactant, 2 2/3 or 2.67 moles of ammonia. And then from there, I asked how many grams that would be. I just have to multiply it by the molar mass. Again, since you have moles, that goes in the bottom. So you put 1 mole is 17.04 grams for ammonia. And when you multiply that out, you get a value of 45.4 grams. So if everything goes perfectly, theoretically, you should be able to make 45.4 grams of the ammonia based on the amount of reactants you have. So that answers the first part of the question. Then, for the second part of the question, I have to figure out how much of the excess reactant remains. Now, we established this is the limiting reactant, and we're going to have some of this left over. We can label that the excess reactant. So if I have 2 moles of that, and I need 1.33, I can say that what I have remaining at the end is 0.66 moles. Just by subtracting what you need from what you have, you know how much is left over. And then if I have this many moles of N2 remaining, and I want to know how many grams that's going to be, then all I have to do is multiply by the molar mass. And when you do that out, you have 28.02 grams for every 1 mole of nitrogen, and that gives you that you would have 19 grams of the nitrogen remaining at the end of the reaction. So this is how we would perform one way of performing limiting an excess reactant stoichiometry problems.